So this is how to mitigate VLAN attacks, because we have what you call VLAN attacks, and then how to prevent the VLAN attacks. So with security, it's a combination. It's a combination. You need to note that so far whatever that we've covered, it's also they are also needed to prevent VLAN attacks. So within the VLAN attacks, we have what you call VLAN hopping attack. It can be launched in one of the three ways. We have spoofing. We have spoofing. Spoofing DHCP messages, which is dynamic trunking protocol, from the attacking host, then to cause the switch to enter in trunking mode. So from here, the attacker can send traffic tagged with the tag VLAN, and the switch then delivers the package to the destination. So this with spoofing here is when if it's this as the switch connected to another switch, and then maybe a PC, this port here, it can be targeted, and then because it's supposed to be the access port, it can be targeted, and then the code is run. The code can be run on this router, so on this PC, and then it ends up acting as a switch, and then it becomes a trunk. Once it becomes a trunk, then it means that it can actually receive traffic from multiple VLAN. So introducing a rogue switch can switch and then enabling track. So this one here, it will be treated as an assimilated switch, an assimilated switch for it to have a trunk link between this and then this. So the attackers can then access all the VLAN on the victim switch from the rogue switch. You're on this PC, but you are able to access traffic from different VLANs from all the switch. Another type of VLAN hopping is double tagging. Double tagging, that from this computer, if the frame can actually have two tags. The outer tag, it is maybe the native VLAN, and this switch, it's not going to tamper with it. Yeah, it's a native VLAN, it's a VIP VLAN. And then when it reaches the other side, now this here, after stripping off the native VLAN, after stripping, because this one here, it will strip off the native VLAN tag and then sends the inner one. And then when the inner one reaches this side, the switch is going to handle each appropriately to make sure that it goes to the right destination basing on the VLAN tag there. So those are the three ways. By hijacking the trunk, creating the rogue switch, and then assimilating a double tagging. So steps to mitigate VLAN hopping. Step number 1, you have to disable dynamic trunking protocol. How are you going to disable that? To make sure that if this side it's trunk, and then the other side it has to be trunk. If this computer, let's say a switch, and this is a PC, this is a PC, it has to be an access, and you make sure that on this port you disable what we call the negotiation. You disable that feature, so that if this cable is connected to another switch somewhere, then it should not negotiate with this other end. Then step number to disable unused port. You see now we are bringing in the previous disabling, because this one here it's disabling the auto trunking, then disable unused ports. Here and here it's obvious. Step number 3, manually enable trunk. Step number 4, disable dynamic trunking auto negotiation. Then step number 5, set the native VLAN to native other than VLAN 1. So you have to make sure that to avoid that VLAN tagging, the double VLAN tagging, you can use any other VLAN that can't be traced. So those are the 5 steps. Then we have mitigate, how to prevent DHCP attacks. Under DHCP attacks, we have something called DHCP starvation, where all available IP addresses within the DHCP pool, they are actually leased out. That the attack, an attack will actually force the service to issue out all the available IP address. Recall the DHCP starvation attack can be effectively mitigated by using port security. So you see now that port security, it's going to cut across in all the services. That the port security, you can use it to limit how many MAC addresses should be allowed on that port. However, mitigating DHCP spoofing attack requires more protection. Spoofing here, DHCP spoofing is creating a rogue DHCP server on the network. So DHCP spoofing attacks can be mitigated by using DHCP snooping on trusted port. I'll show you that DHCP snooping filters DHCP message and rate limit DHCP traffic on untrusted port. That if you have a switch, let's assume you have a switch here connected to a server, the attacker, an attack can actually use just single computer here to starve this server here by sending endless requests. Now, when it comes to access these other connection to other computers, they are treated as untrusted. So untrusted ports, they can be limited with rate limits or limit. And like each computer, at least it has to send maybe 5 requests. So the 5 requests will not actually drain it's not going to starve the server. So trust interface, e.g. trunk link server port must be explicitly configured as trusted. So on those links, where we expect so many requests, like trunk link, like on a server, because you cannot limit a server. A server is there to serve all the computers on the network. But the end device, what would you be requesting for? So the DHCP table is built that includes the source MAC address of a device on any trusted port and IP address assigned by DHCP server to that device. So the MAC address and IP address are bound together. Therefore, this table is called DHCP snooping binding. That each computer, it has to be binded, as you can see, to the MAC address and then the IP address. MAC address and then the IP address. So steps in implementing DHCP snooping. Using the following steps to enable DHCP snooping. Step number 1, you enable DHCP snooping by running this command globally. Then IP DHCP snooping trust, for example, on the interface for the server. And then step number 3, IP DHCP snooping limit rate. Now this one here, it has to be on untrusted port. And then you specify the VLANs. The VLANs to use that port. Yeah, IP DHCP Snooping, then the VLAN. Which VLANs? So here is the lab, and this is what I will actually record in my free time and then share with you for you also to try. So this is our switch. This is the trusted because it connects to trusted device, but this one here is not trusted port. So the syntax, so the step number one, enable snooping first. And then step number two, you call the interfaces and then specify which one is trusted and which one is untrusted. The untrusted, they are all these from 5 up to 24. And then you put the limit rate that they are supposed to send maximum 6 packets. And then still, you can include the VLANs, your VLANs that you're sure that they are available. They are available. If someone comes and creates a new VLAN on the network, then that one it's not going to be allowed. It's not going to be allowed. So it's this, they're available on this, they're available VLANs on this to be part of snooping. That is anything outside this range, then it is not known, or it is going to be regarded that it's going to be actually categorized as unwanted VLAN. So you can go ahead and you verify show IP DHCP snooping. As you can see, snooping is enabled. The VLANs are available there. As you can see, they are here. Yeah. Then what else? The no, the VLAN DHCP snooping is configured on the following interface. The following interface. So what do we have? This. Okay. So when you look at this at port 1 here, it is trusted, yes, allowed option, yes, and then rate limit for packets, as you can see, unlimited. But when it comes to these other ones, so far we have 5, then 6, and so on. So for 5, as you can see, the trusted notch, the allowed option no, but the rate limit, we have 6 there. So you can actually chain because we deal with the MAC address. So this show IP DHCP snooping that you'll be able to see the MAC addresses that are available attached on per interface. Mitigate ARP address resolution protocol. Threat actor can send what we call unsolicited or solicited ARP replies. So unsolicited ARP reply, it's the reply that was not requested from to another host on the subnet with the MAC address of the threat actor and then the IP address of the default gateway. So to prevent the ARP spoofing and the resulting ARP, or that results in ARP poisoning, a switch must ensure that only valid ARP requests and replies are relayed. So there shouldn't be a reply without a request. So there we have what we call dynamic ARP inspection to inspect the replies. Were there a request for those replies? As DHCP snooping and then help prevent ARP by not relying in valid or gracious ARP. The gracious ARP, those are unsolicited ARP replies out to other ports. That once this is generated, it should not be actually relied on. Then intercepting all ARP requests and replies on untrusted. So when it comes to untrusted ports, then the request and replies, they have to be intercepted. Verifying each intercepted packet for valid IP to MAC. Is the IP and MAC address valid? Are they binded together? Or this MAC address, it is binded somewhere else. Dropping and locking ARP replies coming from invalid that are invalid to prevent ARP poisoning. So if ARP replies is coming from invalid device, then it has to be prevented. Then error disabling interface if configured dynamic ARP inspection number of ARP packet exceeds. So if the number exceeds, then that port it should be put in error disabled port. So it's here, as you can see, that this PC, when it comes to this PC, its MAC address together with the IP address, they have to be binded together. So if it happens and find that the MAC address binded with this, now it is in reply from a different IP address, then it should be dropped. Should be dropped. So enable DHCP snooping globally, like what you said, enable DHCP snooping on selected VLAN, still we did this, and then enable DI on selected VLANs. Configure trusted interface and snooping and ARP inspection. So there is a lab here, an example whereby you have to IP DHCP snooping enabled, IP DHCP snooping VLAN this, IP ARP inspection VLAN this. You're going to inspect traffic from VLAN 10. Then after that, you call the interface where you want it. IP DHCP snooping, this it is trust. It is trusted. So it has to be done on this. That all this the inspection, it has to be done on this interface. Then IP ARP inspection, then trust. This is still a continuation with dynamic ARP inspection can also be configured to check for both destination and source, the destination or source MAC address. So it can either be destination IP destination MAC address and IP address, or source MAC address and IP address. So as you can see, we have them here, that it's destination. It checks the destination MAC address in Ethernet header against the target, the target address ARP body, or the source checks the source MAC address in the Ethernet header against the sender. So here it's against the header, and then this it's against the receiver, the destination, together with the IP address. It checks the ARP body for invalid or unexpected IP address, including address from 00 to 255 and all IP multicast address. So this is the range of address. It's from 00000 up to 255, 255, 255, then 255. So this is the range. All the IPv4 addresses that you know, they fall in this or in that range. Here we have the example still about DAI. So if you to enable it, you have to IP ARP inspection, validate. Now what are you going to validate? You can validate the destination MAC address. You can validate the IP address, either the source destination or the destination, the source MAC address. So we have the sample IP ARP inspection validate source MAC address, validate destination MAC address, inspect still validate IP address. All the three they are there. And still here, as you can see, do show run include validate ARP inspection validate IP address. So it's the IP address that is there. Since all of them are enabled, so it's the IP address that is going to take the first priority. So IP ARP inspection validate source destination, and then the IP. So here all the three are included, this source, destination, and IP. So if you do the again, so the inspection, it validates, it has the source against who is sending, which device is sending, and then the destination receiving together with their MAC address. Mitigate what I call the STP, spanning tree protocol. If you have to mitigate to prevent all that, you have to make sure that if you have a switch, two switches, and then a PC here, make sure that this port here, it is in access mode. It's with no negotiation. And then on top of that, you should actually enable BPDU Guard, that if it happens and this cable is connected to a switch, then this switch, it should not send the BPDU messages. And then on top of that, you have to enable port fast. Port fast. That every time you connect to the end device, immediately it goes to forwarding stage. So the steps are here. We did all this when we were actually covering, I think, yes, STP. So the interface list, mode access, port security. So it's spanning tree port fast. Then you can even spanning tree port fast. Default, I explained this, that if you say tree port fast in global configuration mode, then it means that all the ports, they are going to be in port fast. So this one here, you're not supposed to use this. You can use this on a specific interface. So this is globally, this is under the interface mode. And then still we can go for, where is it? The BPDU Guard. Yeah, it's here. So interface still this spanning tree BPDU Guard enabled. Spanning tree port fast. Then this, now there are two ways that this is under interface, but if you want, you can do this in global configuration mode. But if you run this in global configuration mode, it affects all the interfaces. So that is the end of the session.